you because it says you're in the meeting.
It says I'm not in the meeting.
Mm-hmm.
Okay, we'll figure it out. We'll figure it out. So, do you guys see the eyes that are up on the screen?
Mm-hmm.
Do you guys see the
Yeah.
eyes? Can anyone tell me, and please raise your hand electronically, especially since I can't see Alex now, so when he raises his hand electronically, that's the way I can see him. Can you tell me what is unusual about these eyes? What is unusual about them? Now, Haley, we'll start with you.
Okay. So, one's pupil is bigger than the other.
Ah, so who can tell me about that? Why in the world would we want pupils to be bigger or smaller? Sahaj?
So that they take in the right amount of light.
Right. So right now, guys, I have something called a ring light. It's a very, very large circular light that is illuminating me, so it's more even light around me. Okay. Now, that light is very bright. My brain tells my eyes, hey, make your pupils smaller. Because if the pupil is too big, it lets in too much light and it could damage what?
Your eyes.
It could damage what part of my eyes? Brandon, do you know? Al, do you know? Julian, do you know? Go ahead, Brandon.
Your pupils itself?
Well, the pupils are really the part that lets in the light, but what is
blue part?
behind it? What's behind it?
It's like the veins and blood cells and like
Right.
white part.
Blood, we have blood vessels, but does anybody know what it's called, the most important thing? Alex? Oh, Alex, you're also muted. You have to be unmuted to be able to be heard. So I'm trying to unmute you, unmute all.
So the lens.
Oh, the lens. Yeah, it's called the retina.
Oh yeah, that too.
It's called the retina or the optic nerve. Okay, so it's the retina and optic nerve that are really most important here. Now, when you go to an eye doctor, how many of you have had glasses or contacts or anything like that? Julian, how about you? Alex?
I have glasses.
You have glasses. Okay. Well, so does Mr. Kramer, as you can see. And every time that I go to an eye doctor, they put these drops in my eye and it makes them dilate.
Oh, yes, I've got them dilated.
And it dilates to a factor of what? How much bigger is the radius of the larger pupil to the radius of the small pupil? Who can raise their hand on that?
That's the printer plug.
No, this is the screen.
Who can raise their hand on that one? How many times bigger is this larger pupil than the smaller one? How many times? It's called a scale factor. Who's going to give me that scale factor? Come on, nobody's got any ideas? Is it 5 times? Is it 10 times bigger? Is it 100 times bigger? Or is it maybe not that big? Haley?
8 times.
So you think that this diameter, this red diameter, is 8 times the smaller diameter. Okay, that's a great start. Thankfully, somebody had the courage to get started. Come on, you guys, everybody, take a guess. What do you think it is, Sahaj?
3.
Yes. Guys, do you see how this is 1, 2, 3 times bigger? 1, 2, 3 times bigger. So we say that it has a scale factor of 3. Now, here's the challenge question. What happens if we go from the large to a small? Who knows? Flag in, please, with your hands raised electronically. What would the scale factor be if we go from big to small? Serena.
It would
I mean, if from small to big is 3 times, then from big to small would be what?
-3.
Ooh, that's kind of a really cool guess. Not a -3, but I love it. Alex, what about you, buddy?
I was gonna say -3 as well.
Oh, I think that's a great guess. I really do. Sahaj, what do you think?
Divided 3?
Yes, but you have what is it when a fraction is divided 3? What is that called? You guys are gonna laugh when I show it to you. Guys, it's a factor of 1/3. Right? Isn't it, if I go from 1 to 3, it's a factor of 3. When I go from 3 to 1, it's a factor of, come on, say it, guys. 1/3. By the way, somebody is eating crackly sounding food. So if you can stop doing that, that'd be great. I have another idea for you, Sahaj. Sahaj, you can also put it in a bowl, and that way, every time you put your hand in the bag, it doesn't make a crackling sound. Does that make sense?
Actually, I'm eating on a plate and I'm eating peanut butter sandwich.
Okay, so there's somebody else with a crackly
That
food.
was me, and I just stopped.
Oh, okay, thank you, buddy. I appreciate that. Now, guys, scale factors are important. Do you know that most people, including adults, would say that the dilation is only when something gets bigger? But guess what? It's not true. A dilation of a scale factor of greater than 1, so if the scale factor is greater than 1, it gets bigger. If the scale factor is less than 1, it gets smaller. Who can tell me what happens when the scale factor is equal to 1? Please flag in on this one. I'd really love to hear what you have to say. Okay, we're going to start with Sahaj and then Serena.
Does it stay the same?
Yes, guys, it's no change. It is no change. Now, here is the big question. Are you ready for this? And Serena, you had no change? And Haley, does it make sense that a scale factor of 1 is no change? Okay, Julian, I want you to look at yourself in the screen right now, and I want you to multiply yourself by a scale factor of 1. Julian, did you change? Julian, did you change? I just want to know that I could hear you because I haven't heard your voice yet. So can you speak so I know that you can hear me, Julian? Can you speak a little bit louder? Okay, so Julian, your sound is turned off. I just want you, you're not muted, but your sound on your computer is turned off. Can you push a button on your computer to turn your sound on, please, or have a parent help you with that? Because that way we can hear you. Right now we cannot. Try to speak again.
Yeah.
Oh, great. You know what? It was your headphones. Okay, so keep your headphones off. Now, Julian, if I multiplied you to a factor of 1, would you change at all?
No.
Not at all. Now, here's my question for Brandon. Brandon, what if I multiply you by a scale factor of 0? Brandon, what's going to happen to you? What's going to happen to Brandon, guys?
I'm gonna be a 0.
But what's going to happen to him?
He'll disappear.
He'll disappear. Do you see how I just made him disappear? Okay, so it literally would make
No.
you disappear. Now, let's play my favorite game.
Yay, I love
I've
chess.
got a scale factor of 1 chess piece. Who can tell me the scale factor of the smaller dilation, don't say it out loud, and the scale factor of the larger dilation? So please flag in on that. I'm looking for both the small and the large. And I want your hands up here. Alex, give me the small, please.
I think the small is, if the original is 1, then I think maybe the small is 1/3.
All right, I'm gonna write that down. Anybody else have another idea? Go ahead, Haley.
Half.
Half. Okay, you know what I'm gonna do? I'm gonna write your answer in, but Alex, I want you to watch this. Alex, I'm gonna take this height and I'm gonna put it up against this guy. Do you still think it's 1/3?
No,
What do you think it is now?
1/2.
And don't take my word for it. Let's look at the width. And look at that. The width is also 1/2. Okay, Julian, can you give me the scale factor of the big, please?
I think it's, well, it's,
Oh, I know.
And Julian, watch what I'm doing here.
it's 2.
Yeah. Yeah, did you guys all get that?
Yes.
Yes, it's a scale factor of 2. Now, guys, what would happen if I dilated it to a scale factor of 0? Go.
It would disappear.
You will disappear.
It's gone.
Nothing.
Wait, it's not exactly gone, sorry. But the beauty of this, guys, is that you know that dilation is about multiplication, yes?
Yes.
Watch
Yeah.
this. Are you ready for this? This is gonna be fun. We're gonna take little a triangle and we're gonna dilate it by a certain scale factor to make the B triangle. Who can tell me the scale factor from A to B? So we're going from A to B. Everybody say it on 3. 1, 2, 3, go. Come on, what's the scale factor from A to B? Go.
2.
It is
2.
Guys, look at this. How do we know it's 2? 2 times 2 is
4.
and 3 times 2 is
6.
6.
and 5 times 2 is
10.
and 1 times 2 is
2.
So now, ladies and gentlemen, mathematicians, can you tell me the scale factor from A to C? And don't say it out loud yet. Don't say it out loud. But what I do want you to do is look at the coordinates and tell me what you think. On 3, 1, 2, 3.
4.
4.
Absolutely, scale factor of 4, but it's only when you go from A to C. What happens if you go from B to C?
2.
2.
You got it. You got it. Now, challenge question. What happens when you go from C to A?
1/3. No, 1/4.
1/4.
Ooh,
1/4.
good, 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 good. That's a 1/4. Now, guys, I want to show you something really cool. Whenever you do dilations on a coordinate grid, it has the most amazing effect. Watch this. Do you guys see the origin right here at 0, 0?
Yeah.
Now watch this. 0.23, 0.46, 0.812. Are all those points on the same line?
Yeah.
Yeah.
How about origin? 2, 1, 4, 2, 8, 4.
8,
Are they
4.
all on the same?
Yes.
Yeah.
And of course, the last one. If you've ever seen artists use something called perspective,
Oh, it's like a 3D triangle.
exactly. So when artists back in the old ancient days of Italian art, there was no perspective. There was no 3D. Everything looked very two-dimensional. And do you remember that? Have you been to a museum where everything looks very two-dimensional? And then you kind of get past the Italian early stage and into the Renaissance when they started to use lots and lots of perspective. And it's all about dilations. Now, I don't know what page it is in your packet, but can you go to a page that has a knight on it and it looks like that? I think it may be page,
7.
is it?
Yeah, page 7.
Page 7, huh?
Yep.
Okay.
For me, it's 6.
Okay, so go to the page, exact page that you see on my screen. Brandon, are you there?
Yep.
Julian, you're there? Oh, Julian's got it. Cool.
It's 7, I'm pretty sure.
It's 6.
You know what?
It's 6.
Doesn't
Oh
really
yeah, it is.
matter-
Yeah, here's 6.
It doesn't really matter if you already are there. Now, let's start with a point, and I'm going to make this a little bit bigger. Can you guys tell me the point right here?
Where?
His nose, the nose of the knight. Who knows what point, who knows, no pun intended, who knows what point that is? Everybody say it on 3. 1, 2, 3.
Negative 3, 5.
5.
All right. Now, negative 3, 5. Now, what I want you guys to do is this. I want you guys to dilate this knight to a factor of 2. So scale factor of 2. What point is negative 3, 5 doubled to a scale factor of 2? Everybody say it on 3. 1, 2, 3, go. Come on, double the negative 3, and then double the
Negative
5.
6, 10.
Negative 6, 10.
And guess what, guys? It's negative 6, 10 right up there. Now I want everybody to do the same thing with this point here. Who can tell me what that point is? Please raise your hand electronically. Serena?
0, 6.
Ooh, so sweet. Awesome job. And who can tell me the doubles? Sahaj?
0, 12.
Whoa. And guys, do you see that it's literally off the grid? So 0, 12 is actually off of my grid. And then I take a line and I connect those 2 points. Now, guess what I want you to do? I want everybody to finish a dilation factor of 2. And when you're done with that, I want you to do a dilation of 1/2. 1/2 is going to be a lot harder. The point negative 3, 5, guys, what would that be in a 1/2 dilation? What is half of negative 3, guys?
Negative 1 1/2.
Negative 1.5.
Or we could just say negative 3/2. And what is half of 5?
Negative 5.
It's just 5/2. So if you
That's
want
2.5.
that point, go to negative 3/2 right here and go up 2.5. And that point will be right there. So I want you guys to start working on and start with the dilation factor of 2. Start with a dilation factor of 2, and I'm going to do the same thing. And if you hit a wall at any point, if there's one point you're having trouble with, I can't find it on the original or the dilation, you let me know. Okay, what point are you working on, Julian?
Mr. Kramer?
Yeah, hold on a second. Julian, which point are you working on? I just want to make sure that you're working on one of those points. Can you say it out loud, Julian?
Working on this point.
You can't say this point. You've got to identify it
The
with
nose
numbers.
point.
Say again?
The nose point.
Oh, good, good. So the nose point, -3.5, is -6.10. And then the top of the head goes from 0.6 to 0.12. So now you want to go to the next point. And Serena, your question.
Mr. Kramer?
Yes.
I don't have my work right now.
Oh, okay. So you know what I want you
It's
to
downstairs.
Oh, then you know what? Go get it. Because if you can get from here to downstairs, it would be helpful to have it now. So go for it. Go for it. And all right, Haley, how you doing there? Oh, Sahaj, you had a question.
No, you answered it. I was just wondering what we should dilate.
Yep, factor of 2 and a factor of 1/2.
Mr. Kramer,
Yes.
can I go to the bathroom?
You don't have to ask.
Okay.
Whenever you need to go, you just go and I'll know that you had to go to the bathroom. But if I have to go, I'll ask you guys. Wow, this is getting big, huh? Uh-oh, I'm running out of room. So 2 -4 goes to 4 -8. Anybody have any questions? Oh, you got it. Great. And remember, guys, you're not going to finish everything we start today. We're gonna do a little bit of this, and then I have many other challenges you can all do during the week. And Alex, how are you doing, buddy?
Good.
Great. Uh-oh, I'm on the belly. Does anybody have any questions yet, or is everybody able to get every one of these points so far?
Yeah.
You're
Yep.
good so far, Haley?
Yeah.
Okay, great. Brandon, you too?
Yep.
Great. Julian, you good?
Yeah.
Serena? Sahaj?
I'm good.
Okay, great. That point was -1.3, so -2.6. Yep. Makes sense. All right, so I have finished the dilation of 2. And now I'm going to start the dilation of 1/2. Maybe I should make that blue. All right. Oh, wow. Hold on. Whoa. That's too big. That's going to be just right. Can I see your progress so far? Can anybody show me what they've got? And Alex, what you can do later is you can take a picture of yours and email it to me, and I'll actually post it. Okay?
Okay.
So everybody can see it. It'll be really cool. And Brandon, can you show me where you are? Sahaj, Julian, Serena, and Haley?
Oh, I'm doing this on a computer.
Oh, you are?
Yeah,
How's that working?
good.
Excellent.
Though the lines are kind of wobbly.
Yeah, because you're not able to use a ruler, right?
Yeah.
Yeah, I think you may want to use paper from now on, Haley.
Okay.
My ruler.
Let me see yours, Brandon.
This?
Oh, that's a good ruler. That's a nice ruler.
What?
I like that ruler.
Sure.
Yeah, well, I like yours too, Serena.
I finished dilating it by 1.
You mean by 2?
2.
Now, if you dilated it by 1, Alex, you could
Yeah.
go, oh, I'm done.
Uh-huh.
Right?
Yeah. That's not what I meant.
I know. And now you're going to do a dilation of 1/2, yes?
Yep.
Or why don't you do 1/10? No, I'm just kidding. That would be too small. So 2/4 would be 1/2. 1/6 would be 1/2 3. You know, it's funny, dilating to a small factor takes a lot more concentration, at least for me.
Yeah, because you have to make the lines just right at like the halves.
Right, I would say that's true, but it's also harder to make smaller lines, I think, Alex, than to make bigger lines. And there we are.
It's pretty small.
I'm gonna give you guys just another few minutes.
Can we color them in after the lesson?
Alex, guess what? Look at what I'm doing right now.
Then I guess we can do it right now.
You can do it. I gotta tell you, I love coloring in my dilated figures.
Can I use pen?
You bet you can.
Because then it's actually like a work of art if you color it in.
Oh man, it is a work of art.
It can look like a piece going into a shrinking machine and then coming out again.
Yeah, it's pretty amazing what you can do with dilations. But anyway, guys, I want you guys to watch what I'm doing right now. I'm going to show you all 2 dilations of a double and a half. And you can see that it kind of goes in and out, in and out. So dilations, they require a scale factor. And now let's take a little journey. If you can go to the page where you see a small k.
That's page 8.
That's page 8. Okay. So go to page 8. Go to page 8, and I want you to dilate that to a factor of 3 and then 1/3. So, and Julian, can I see where you are right now on the night? Just show me where you are on the night, because I wanted to see your work. Oh, beautiful job. Really nice job. Haley, how about you? Oh,
Good.
I can't see yours. I can't see yours. Sahaj, what about yours?
Almost, and I just couldn't get the spacing right up top. See?
Hold it steady, buddy. Hold it steady in front of the camera. Oh, that's nice. But you know what though, Sahaj,
Yeah.
I'm not sure I agree with I'm not sure I agree with all your points. So Sahaj, can you come back down to the computer so I can see you? Sahaj, I still can't see you. Now move your paper to the left. To the left. There you go. Okay. So Sahaj, I want to talk to you about a point. Okay, you ready?
Yep.
This point right here, Sahaj, -1, 3. Look at the point -1, 3 right here. Do you see it?
Mm-hmm.
Now, Sahaj, when I double -1, I get -2. When I double 3, I get 6. So that point gets dilated to -2, 6.
Wait, is it when you dilate by 3, you triple
You
instead of
betcha.
double?
You betcha.
So would the point -2
Oh.
so would the point -2, -3 be -6, -9?
Did you say -2, -3?
Yeah.
Yes, -6, -9. And Sahaj, do you see the mistake?
Yep.
Okay, good man. Good man. Okay, everybody, I'm going back to that page 8 now. And I'm going to start dilating to a factor of 3. Now, Alex asked a really good question. I'm hoping that you guys ask good questions too. Who has a question about dilating to a factor of 3? Anybody? Okay, then I hope that I can see some really good dilations. I'm going to start with -2, 3, which goes to -6, 9. Does that make sense, Alex?
Yeah, that's what I started with.
Oh, okay. So you were not talking about -2, -3.
No, I thought I said
Oh,
-2, that's what I said, -2, -3, I'm pretty
yeah.
sure.
Well, that guy becomes -6, -9, all the way down here.
That's where I placed it.
Yeah, nice job. And make sure you raise your hand electronically if you have a question. The worst thing in the world is to have a question and not ask it.
That's the worst thing in the world.
Oh, it is. It is. Because to me, ignorance is the worst thing. Ignorance is when I don't know something, and I love knowing. So if I don't know something, I'm going to ask you a question. Like, for instance, I don't know how Haley got on top of the Golden Gate Bridge, but I should ask her. I say, Haley, how'd you do that? So 2, 3 would be 6, 9. Whoa, that doesn't look right.
What's the other thing we should dilate it by? I finished dilating it by 3. 1/3?
1/3. Now, Alex, this is going to be a little bit harder. And so here's what I want you to think about, okay? Alex, I want you to think about, and Alex, look up at my screen for a second. I'm just going to write the number -2, +3, okay? And I'm going to dilate that to a factor of 1/3. Now watch what I do with the numbers. I'm literally going to divide, like Sahaj said before, I'm going to divide each of these by 3.
So it would be -2 and then
Wait, -2 thirds, comma,
and
1.
1.
You see that? So -2 thirds, comma 1. And that's because I simplified 3 thirds but that's the way I like to do those. Let's see. Next one.
This is my -3 of the small cake.
Oh my God. Dude, you totally nailed it. Let's see you do the 1/3. This is going to be harder. And Sahaj, if you want to ask me any questions about a particular point, this will be a good time to do it.
How do you do 1/3?
Well, okay. So do you see, Sahaj, wait a minute, hold on. Do you see that I started with point -2, 3, which is right here?
Mm-hmm.
And do you see how I
It's never-
literally divided each of those numbers by 3?
Yep.
And -2 divided by 3 is just -2/3, but 3 divided by 3 is actually 1. So -2/3, 1, and let me show you where I put it. You ready? -2/3 would be right around here, and +1, and so it's right about there. Okay?
Okay.
Wow.
Dilating it by 1/3 is really small.
Oh my God. It's a little ridiculous. It's a little hard to do, but you know, that's what mathletes do. They challenge themselves all the time.
It wouldn't be fun if it wasn't a challenge.
Yeah, I agree. Some things can be okay if they're not challenging, but I always like a challenge too. But it's not for everybody. Everybody has their own way, Alex. Everybody has their own way.
I finished dilating it by 1/3.
What?
So now color in both of
Who
them
said
and
that?
make a beautiful piece of artwork.
Both of them? All
Yeah.
of them? Okay.
Absolutely. So 2/3, 1. 2/3, 1 would be right there. And that would be -2/3, 1, -2/3, 2/3.
Who's doing that?
Yeah, whoever's making that noise, it would be great if you could not.
What noise? I don't hear anything.
Yeah, somebody's got like a ringing in the background. It's distracting to some of the kids.
Yeah.
That's my brother.
Okay, so then you can mute yourself, and then when you need to talk, you just unmute yourself.
I stopped him.
Oh, good. Brothers can be so compliant. Whoops. Wow. There it is. Can I see any, Brandon, can I see yours?
Mine is an M and I'm still working on it.
Oh, you're working on the M. So did you do both Ks?
Okay.
Yeah, I mean, do you see my screen, Brandon?
Yes, I do. I do.
Okay, so we're working on the Ks. So why don't you go work on that?
Okay.
And there's somebody who's got I think it's Alex. I'm going to mute you, Alex, and you can unmute yourself. But I just know that your brother is continuing to talk, which is fine. But I just want to make sure that everybody else.
Finish the big K.
Okay, cool. So now, everybody now, I want you to go to one of the big challenges. And the big challenge is the circle challenge.
Ooh.
So, Alex, I don't know if you know what page that's on. I'm going to unmute you now. It's one of the
14.
it's one of the last pages.
14.
Yeah. Now, who can tell me, first of all, don't say it out loud, what kind of a polygon is that? How can you identify that polygon? And Julian, are you on that page 14? Okay, cool. So who can identify that polygon? And if you can, send me a chat, please, with the number gone. So let's say you think it's a 40-sided, you would say 40 hyphen gone. Okay, nobody has any ideas?
Nope.
So nobody was able to sort of think of an algorithm and a way to count? What about you, Serena? What about you, Haley? Sahaj? Alex?
Is
Brandon?
it
Julian? Remember, it is cut into quarters.
Is it? Okay, I'm gonna
Haley.
chat you.
No, Hallie, you can say it out loud, kiddo.
Okay, is it 20, 28?
Well, 28 would be true if each quartile had 7. So that's 1, Haley, 2, 3, 4, 5, 6. But Haley, isn't this one part of the next group?
Oh.
So it's actually 6 times 4. And Alex, you can say it out loud.
24.
I'm pretty sure I said in the chat 24.
Excellent. So it is a 24 gone. And the way I did that was I just counted 1 quarter, which was 6, and I cut it, I multiplied it by 4. Now, if we were to do a scale factor of 2/3, I want somebody to choose one of the original points, and we'll use those as our starting off point. Who's going to choose an original point? Go ahead. Come on, Sahaj.
how about -10, 1?
All right. Do you guys all see -10, 1? Yes?
Yes.
Yes.
Watch this. Watch what I write down. -10 over 1, because isn't -10 the same as -10 over 1?
Yeah.
Yeah.
Okay. Now I want you to watch what I do. I multiply it by 2/3. Do you all see what I just did?
Yeah.
Now,
Yeah.
everybody help me multiply numerators and then denominators. So go ahead, numerators go. -10 times 2.
Negative
Negative 20.
negative 20.
And then 1 times 3 is?
3.
3.
3.
And then 1 times 2/3 is what?
2/3.
Third.
So
2/3.
Oh.
-20/3 and 2/3. Everybody plot that point, please. Now, -20/3 is -6 and what? Come on, -6 and? Come on, guys. What
And
is
Half.
20?
Half.
What
No,
is 20 divided by 3? 6, remainder
Remainder 2.
2.
So 6 2/3. So it's right there. But now we have to go up 2/3. So we get in the elevator and we go up 2/3. And there we are, guys. You just plotted your first point. Now get started. And I want you to ask me a lot of good questions here. We have about 5 minutes for you guys to ask me some really good questions.
Okay.
So who's
Kramer.
got those really good questions?
If it's negative 6 2/3, why did he put it inside a space?
Well, negative 6 2/3, Alex, and then up 2/3. So the elevator is negative 6 2/3, negative 20/3. That is a great question.
Can I go to the bathroom?
You don't have to ask. Negative 6 and 8/3. Negative 6 and 2 2/3. Wow. Negative 8. 16. 5 1/3. Negative 5 1/3. And 4. Wow. Julian, how you doing there, bud? Good? Alex, you too? Doing well? Give me a thumbs up. You can even have a response that, oh, excellent. How about you, Sahaj? Good? You, Haley? Brandon? Awesome. And negative 6 would be negative 4. Negative 4 and 5 1/3. Negative 4, 5 and 1/3. Wow. Negative 8/3.
Yes, yes. Thank you. Yeah, the Quincy one, yeah. Right. Yeah. Okay. Thank you so much. Okay. All right. Talk to you soon. Yeah. Bye-bye.
Oh, what time is it?
We have about 2 minutes. And that one is negative 2/3. Six and 2/3. Negative 2/3. 6 and 2/3. And then 4/3 is 1 1/3. Wow. All right, guys, everybody stop for a second. Everybody stop and look at Mr. Kramer's first curve. So I have completed 1/4 of this diagram. I have completed 1/4 of the diagram. And if you guys can go through all of these, you're going to have a lot of fun. But here's the best part. The best part is that you create your own little design. So I would start and I would create something, and I'm literally doing this totally at random right now. And if that were your original, you could then dilate it to any factor you want. If you want to get bigger graph paper, you can dilate it like that. But I want you to have fun learning dilations because that is actually how computers work. Computers use different coordinates and they literally multiply and they divide, multiply and divide. And the reason those, and guys, everybody look at me in the eyes for a second. The reason why that works is because of multiplication. It preserves what's called proportionality. The original figure is proportional to the dilated figure, okay, at whatever scale factor you want. Going back to the chess piece, guys, everybody look at this chess piece. Dilate bigger, dilate smaller. Factor of greater than 1, factor of less than 1, factor of 0, factor of 1. So everybody, let's right now go from -10. Are you ready for this? We're going to go from -10. No, let's go from -12 by 1.5. Are you ready? Serena, get ready, go. -12.
-12. -10.5.
10.5.
-8. 9.
Nine.
Negative
-7.5.
-7.5.
-6.
Six.
-4.5.
-1.5.
-3. -1.5.
But don't ever say -0, 2, 4, 6, 8. Who do we
We
appreciate?
appreciate
Mathletes, go mathletes.
mathletes.
Have fun dilating, okay? If you do go to a doctor's office, ask your doctor, say to your doctor, hey, what is the scale factor of my dilated eyes? And see if your doctor knows. And if she doesn't or he doesn't, you teach them the art of coordinate dilation.
No, I'm not.
I'll see you guys in a week. Have a great one. I'll miss you. We'll have some fun next week. Take care.
In exactly 167 hours, 58 minutes.
No, 166 hours and 58.
Yeah. Yeah. 1
Okay,
hour
guys.
off.
Love you. See you soon.
And
Bye.
13 seconds.